Welcome to Saving Tortuga. In today's episode, we're going to fabricate and install a windshield. The boat didn't come with a windshield, so we're starting from scratch. So, welcome aboard. I used 1/4-inch polycarbonate sheet, or Lexan, in the build process. The first step was to lay out the pieces. Polycarbonate is very expensive, so you want to make sure and make the most of what you've got. I used a special blade I got. It's made by Bosch. It's specially designed to cut plexiglass, and it did a really nice job and left a really good edge as long as you go pretty slow and careful. Here's a time-lapse view of the process. Here are the pieces all cut out and laid out on the deck. The next step was to mock the pieces up to get a general idea of the fit. Then I had to sand down each piece to get rid of the variation from the jigsaw. Next, I created a template to get the exact dimensions of the slot that they had to go in. I cut out the template, or the pattern, and applied that to an old piece of plywood that I could use as a jig. The next step was to take a piece of Lexan and practice bending it to try to get the three-dimensional shape that I was going to need. I used a smaller piece and was able with a heat gun to eventually get it to conform to the shape of the jig. It wasn't an easy process, and it takes quite a while, maybe 10 minutes of heating to get it soft enough to actually conform. With the success of the test piece, I tried it on the port side panel. Unfortunately, the heat gun just can't generate enough heat to cover the larger area of the port side panel. It was a nice try, but just didn't work. So for plan B, I took my templates and put them on some sheet metal and cut out some molds. I left a few tabs at the bottom so that they could fit right underneath the jig. This would create a three-dimensional area that I could hopefully heat the Lexan up and press it against the mold. I created 2 templates so that I could do both the port and starboard side using the same jig. I used the same pattern and jigsaw method as before. The first try I did was using a grill, an oven, to heat up the Lexan. In this case, it just didn't heat it enough. I got some bend, but not a lot. So back in the oven it goes. This time I got a lot more bend. And it really almost conformed to the mold. but still not quite enough. back to the oven again. This time, it was hot enough. It's jelly. Nice flexibility there, and it just fit right into the mold almost immediately. If we hadn't have melted the center part. The trouble is the oven's just not consistent heat, and I really need like an asbestos blanket to keep the heat off the bottom so the piece is being heated from the circulation on the top. Here's another view of the same thing. You'll be able to see where the heat actually melted the Lexan in the middle. We smoked it, but no, got too hot. Got the shape, but it got too hot. So, plan C. We took some propane burners, space heaters, and set them on a tinfoil base, and then had our jigs, the molds right in front. I'm taking the correctly cut out piece of Lexan, fresh piece, and we're just going to put that in the mold and heat the Lexan until we can just push it outward and bend it into the correct shape. There's two clamps on either end to clamp the piece in place so that we can press against it and get that correct shape. And you'll see in the beginning that the Lexan, of course, fights you and doesn't want to flex. And eventually, it can take 15 or 20 minutes, it gets to the point where it holds the shape. Here we've got the first burner going. Now we're getting the second. So now we've got the Lexan heated up and it's starting to hold its shape. Little time-lapse view. And we get enough, turn the heat off and you can see the curve. Now we'll do the port side. Same process. Just heat that Lexan until it finally gives and bends right into the shape of the mold. It's not necessarily the temperature, but the temperature and the duration before you get that level. And here they fit perfectly into the 1/4 inch groove on either side. So it was a success. Next, we needed to clean the old supports, which had some old foam or rubber gaskets. We needed to clean all that material off. Time for a little hand scraping with an old chisel. Here are the inside supports cleaned up, and this is what the outside looked like after a little acetone and wire brushing. We use a roll of neoprene. It's a 2-inch wide roll I got off Amazon. Ordered 2 rolls 10 foot long each. Just use a black marker. It shows up pretty good on the neoprene. And these will be gaskets that will sandwich the Lexan pieces so they don't crack. You always want to be careful with the bolts and drill holes that are bigger than the bolts. You don't want to put any torque on that Lexan because it will crack. Certainly don't use any flathead screws. You want to use round head so it applies a nice even pressure, and you really want to use a washer. In this case, the supports will really spread the load out, and the neoprene will cushion that any pressure built up on the Lexan. We cut out each piece. I used a leather hole punch to punch the holes in the neoprene gaskets. It's kind of tough material to get a hole into because it gives as it's rubberized. The hole punch worked great. Now we test fit, make sure that all the holes line up. We've got the bracket, 2 gaskets, and the inside bracket to line up. Final test fit with the piece of Lexan. Now we do the next piece. Sometimes we have to do a little trimming to make sure the holes line up. That's better. Once we get our dry fitting on each piece, ready to drill the holes and put the bolts in. And here's the finished product. A little trimming on the gaskets would help. And for this project, we're done. Thanks for watching.